Hello everyone, welcome to the Designer webinar for model preparation for additive manufacturing. My name is Peter Leitner. I am Senior Product Engineer for the Additive Manufacturing Suite here at Hexagon. And in short, I want to present you the Suites. Suites is a compilation of Hexagon software products designed for various industrial fields. So we have the Hexagon Additive Manufacturing Suite, which consists of certain products, the Mold and Die Suite as an individual industrial field, and the Production Machining Suite available. And there are some enabler products where Designer is one of it. And in detail, I want to go into in the Hexagon Additive Manufacturing Suite, which consists of 4 software products. Designer, where we want to deep dive today in, AM Studio and SIMUFACT Additive and Esprit Edge. Designer is CAD for manufacturing and design reviews, so you can make design reviews, you can generate geometries, or you can design in Designer. And parts and stocks can be prepared for working for milling definitions and so on and so on. And the underlying technology is a direct modeler, which allows instant modifying of a certain geometry. I want to go into that in detail later on. If we look at the circle from quote to delivery, Designer is placed in the first or at the beginning of the circle or the workflow. It's in quotation and planning, as well as in preparation and manufacturing. Next product is AM Studio, which is more or less the data preparation tool for metal additive manufacturing. In AM Studio, you are able to orientate the part. You can define the support structures, the positioning and nesting of parts. You can run a quick mechanical strain analysis or simulation. And last but not least, you can generate a build file for the 3D printer. AM Studio is in the circle of quote to delivery, also at the beginning from step 2 to step 4. Before the printing of the part, all the steps are done in AM Studio. The third product in the Additive Manufacturing Suite is SIMUFACT Additive, powerful and scalable process simulation for first-time right metal additive manufacturing. You have fast meshing capabilities, and you can predict the distortions of the part in an early stage before printing. You can optimize based upon this distortion prediction. SIMUFACT Additive is in the circle, again in the data preparation area and in the process simulation and optimization steps. And last but not least, we have to post-process nearly every part, or we CNC finish the additive parts in Esprit Edge, where you can, it's a CAM software for CNC milling for 3 to 5 axis turning and mill turn, and a bunch of other functionalities available in Esprit Edge. And Esprit Edge, or the CAM, is also in the printing and post-processing be found. All these products can interoperate within Nexus, which is a platform to share products or to share to share projects with the different software products, so that automatization and collaboration of all these products is guaranteed. And we are focusing today on Designer, and here especially for the CAD for manufacturing. And we want to learn how Designer can help to prepare cut data for the additive manufacturing, how we can do a cleanup or repair of a model, defeaturing, changing some diameters and offsets, and so on and so on. But I don't want to bore you, so I want to directly jump into a live demo. Okay, so I started AM Studio, I started Designer, And the default for users is the default theme where you have all the functionalities available which Designer can offer. And in the next version of Designer, in the 2024.4 version, theme, which is called Additive Theme or AM Studio Theme, will be available, where we made a subset of all the bunch of functionalities that Designer can offer in an own theme, where you can find the most common functions which are necessary in the additive world. Designer, as I mentioned before, is in general is a direct modeler. What means direct modeling? Direct modeling allows you to quickly shape geometries without worrying about features or constraints. What I mean with that is, for example, I want to design here a simple cube structure, something like that, probably. So yeah, something like that. And what I mean with direct modeling is you can now change the topology of the part pretty easily by simply, oh, that's the wrong one, sorry. You can change the part pretty easy by simply dragging and dropping some features, and you get a new topology or a new design out of it, but it still remains as one body. It's still the body that is here. It's similar to shaping a DAO by pushing and pulling features. And this is what I wanted to mention here. So when I add here some blends, for example, onto the part with a certain radius, you can simply change the radius pretty easily. But as you can see, there's no feature listed here on the left-hand side which says that this solid has a certain blend on it. So that's a bit different to a parametrical approach of designing a feature. Sorry. So I want to add here all, for example, and as you can see, there's no change in the this hole or this blends were not listed in the structural tree anyway. Where you can access to the features is in the undo history, which I sometimes like to work with. So you can, for example, edit the diameter of these blends pretty easily by accessing the undo history, or you can simply select that feature, right click on it, and then you can simply change a certain feature of a part. But it's never been listed on the left-hand side. That's what I wanted to point out. The benefit of that is why we use, or why Designer is based on direct modeling, is it's very beneficial to make to be very flexible and very fast in designing some features, like for the milling, a clamping device or something like that. You need this clamping device once and not a bunch of time, where a parametrical CAD would be more beneficial. But for the things that we need, the CAD, the direct modeler fits perfect to our needs. Okay, that's what I wanted to point out with the direct modeler. And now the standard workflow for additive is the customer, the user, which has to prepare, or which has to print the part, gets a certain geometry. So this geometry is designed from another company or from the developer, for the design department inside my company. But I have to deal with the design that I get, and I have to work with what I have available here. And sometimes you get a topological optimized part like that. It is a step file, so a neutral file format for CAD export. And I now wanted to have a look on the features which are available on the part itself. And what immediately comes to my mind is, why is this not only one surface? It looks like it should be one surface. And there I want to point out the defeaturing functionalities in Designer. And the first thing I want to show is the replace faces feature. So I can select the faces that I want to replace. There's a small face here in the inner as well as here. And the destination surface should be this one. And now I got aware of a bunch of the surfaces which I was not comfortable with, but this blend, as it is visualized here, I'm also not very happy with. So I also want to replace these blends here on that side, and I think they're on the opposite side as well, the blends available. And I want to replace them with the hole so that I get aware of these blends pretty easy. The reason why I wanted to do that is later on, this surface should be offsetted or should be milled by a post-milling procedure, because it should be a very, it should not be a rough surface. It should be very, a smooth surface, because there is something mounted on to that part later on. The next surface which comes to my mind is this one. Again, there are these, I don't know, faces which I don't know where they are coming from, but I wanted to get aware of them. And I'm using the replace functionality of Designer to get aware of these surfaces. And I want to replace it with that bigger surface here. And as it can be seen, this surface is not fully flat. It's a bit shaped. And that's the reason why probably these smaller surfaces are also subdivided from the bigger surface. And again, I want to replace them by one surface, which now is the case. I have one surface where I can work with that much more beneficial than with these subsurfaces. Again, I want to get aware of the blends here and on the opposite side as well.
Evet. Orayı da 10 gün çekebilirsin. Hatta 12 gün geriye. Geriye mi? Sadece buradan çekebiliriz değil mi onu? Bir bakalım lazım ya. Komutlu demin denedim onu da. Olmadı, kestim onu çok küçük.
Yeah, sorry for that. Okay, so now we have these single surfaces where we can later on work with that. And here on the bottom, there are also some features which I don't know where they are coming from, and I don't think they are necessary for that part. Here's a hole which I don't know if this is necessary for printing. I want to get aware of this one. In this case, I want to use another functionality in the defeaturing area. It's called remove faces. And again, I'm simply selecting the faces that I want to get that should be removed, and I activate the remove and heal. So if I only use the remove, then these surfaces will be removed, but there's a hole in the mesh or in the solid, which should not be in there. So I can use the remove and heal functionality. So it's trying to close the surface again, so that we can work with the surface. As well as this hole is a very small hole, which is here a variable, and I also want to remove that one. And there is a surface. I don't know what's the reason for that, but as well, I want to get aware of that. And then we have this bottom surface here, which I think should also be one big surface. And there I want to use, again, the function of replace. You can access to the features or to the functions as well by right-clicking on the surface which is selected. And there you can find favorite features that are favorite functions, which I mainly use. You can add here new functions which you oftentimes use, but I want to use as well the remove faces, remove it by that one. And I end up again with this with this single surface in comparison to the splitted surfaces before. So now we have these holes here. I'm not sure if I want to print them, but we can select these holes and right click on the when we have marked or selected the holes, we can easily change the diameter or the radius of these holes so we can increase it pretty easy, or we can decrease it as well. But to be honest, it's a hole with 1.5 millimeters in radius, so 3 millimeters in diameter, and I think this is more efficient to drill it with a tool later on the milling machine. So I want to get aware of these holes as well by simply removing the faces, and I also want to remove that one, so that these holes are also no longer part of the part. So now we have defeatured our part so that we are comfortable to now do some adaptations onto the part. And one of the most common adaptation which is necessary for additive is to add an offset to a certain milling surface, like these 3 surfaces where we worked on now. And you have two functions available, so there's move or offset. With the move functionality, you can simply select a surface, elements to move, right click so that it's selected, and we can now offset this surface by easily changing the number here, the distance to, for example, 2 millimeter. And what you can see, move takes into account the neighboring surfaces. So as you can see here, the shape which is coming inside the surface I'm working on is taken into account within the moving. If I don't want to have this taking into account of these neighboring surfaces, I would use another function or another function. It's the offset functionality, where again I have to select faces here because I want to offset a face. And now I have offset the variable and thicken. Offset is doing exactly the same as the move, but the thicken is now not taking into account the neighboring surfaces, and it's simply doing an offset onto your surface in the normal direction of the surface. So this can be done on that surface and as well on that surface here. And as you can see, it's doing this offset in the normal direction of the face, and so the shape is also what's also the case for the offsetting or for the thickening is you can see now in the structural tree that we have additional parts or additional solids here available. If I don't want to have 3 individual bodies, you can simply merge them or Boolean them by using the Boolean functionality. I have the target body, which is the main structure, and I add these 2 thickened bodies. And now I ended up again in one single part, which I can work on. Last but not least, I want to offset this bottom surface as well with an offset. And again, I want to use the thickening functionality. But in this case, the offset should be more than the 2 millimeters because the part, as it is, will be printed on that surface. And I will later on cut off the part from the base plate, and a certain thickness is necessary to guarantee that the wire cutting is not removing material from my part. I want to increase the number or increase the thickening distance. Okay, again, I have now 2 bodies, the main body and the thickened body. I will do another Boolean on that part. And now I have the part which I want to later on work in AM Studio, for example. What I also wanted to show you here is you can do a cutting through the part, so you can visualize how the inner of a certain structure is looking like. You can change the cutting angle or the cutting direction, and you can slide through it. Yeah, I think this is a standard feature, which is necessary to get a feeling of a certain part. What I also wanted to show you is labeling functionalities inside Designer. And at first, I want to show you how to imprint a certain logo. To do that, I add a new work plane where this logo should be located. So for example, I want to add this logo on that surface here. So I added a new working plane here, and I import the logo as a DXF file. This is necessary. So the logo has to be converted, or has to be converted in a DXF file so that we can work in Designer with it. When we simply import this logo, then you can see that it's rotated in the wrong direction. So I have to rotate the part first, or the logo first. So now it looks better. And the application point is exactly the origin of the work plane that I have added before. So now I have implemented this DXF file, and as you can see, this DXF file are single lines. So this is something where we can't work with it to imprint it. So I have to make a profile out of these single lines. And what's meant by making profiles out of it, so these single lines were now compared to a certain field, let's call it in that way. So those are more or less the individual letters representing, so that we can now take this profiles and wrap it onto the surface where I want to imprint it. So I have to first select the elements to wrap. Those are more or less the profiles. Then I have to select a reference point, the surface where it should be wrapped on, and application point. Exactly. So now we can see the profile is now imprinted onto the mesh, and by changing the view in the structural tree to colors, or group by colors, I can simply deactivate the profiles pretty easily. And there we can see that's now mapped or wrapped onto the flat surface where I want to imprint it later on. And to imprint the profiles that I have now chosen, I can simply use again the move functionality of Designer. I have to deselect the areas which should not be embossed or imprinted. Oh, take this one. Okay. And I have to define a certain distance. And now we can see I have exposed, or I can expose this logo, or I can impose the logo. That's now on your end, the availability. If you are more comfortable with the expose or impose, I more like the impose, because then it's nothing. Then the surface stays flat, and only the logo is imprinted. Yeah. Now we have imprinted the logo onto the surface, and what we can also do is inside here. Inside Designer, we can add certain structures where I think which can be problematic later on in the printing. So, for example, I want to add a cylindrical structure to, for example, this point here. Give it more stability, and as you can see, I have now subtracted this this additional structure, and you can add this structure as well. and I want to decrease the diameter, for example, to 2 millimeter diameter. And now we have this rod structure added to the structure itself as well. Last but not least, to get the part later on in AM Studio. So AM Studio is working on a mesh base, so you always have to generate meshes out of the CAD surfaces. You can use the functionality of convert to mesh. I like to convert the mesh on my own, because then I can treat all the different parameters here. So I can, for example, change the size of the individual triangle meshes pretty easy by simply increasing or decreasing this value here. It's the maximum number of facet or maximum facet width. So I can make it bigger or smaller. I have deactivated the deviations. So there are also possibilities to change to work with the accuracy of the measurement. So this part is finished. I can send it to AM Studio. This is more or less an export step. So I can export the STL file to a certain directory. Clicking on save will now store the file in a certain directory. And yeah, as I mentioned before, in AM Studio, we have to work with mesh structures. And that's very common in general in the additive field, to work with meshes in comparison to work with CAD or native CAD files or step files or something like that. So in short, I also wanted to showcase you how you can work in Designer with the mesh model. So I imported a pretty easy part, to be honest. If it's the best part to print, it's another discussion, but yeah. I imported a step file, and as you can see, it's one closed mesh. So if I can't select any surface here. So first thing I have to do when I work with meshes is to extract the mesh edges. Simply selecting it highlights the edges which are detected, and you can very easily again play around with the accuracy. So as you can see beforehand, there was this edge detected, and by simply changing this parameter here, you can get more edges out of the part. Now I've assigned that, and as you can see now, I can select all the separated faces, but as you can see, it's still one closed mesh. It's only the possibility of working with the individual sub areas, more or less. And what I wanted to showcase here is, so I can now take this hole here, and I can now, for example, make an offset onto that. As you can see, it's now remeshed and it's offsetted into the inner 1 millimeter, or from, for example, 2 millimeter to the inner. Or what I can also do is I can move the whole in X, Y, Z direction. So for example, I want to move it 1 millimeter to the left and 1 millimeter in Z for whatever reason. So you can, again, very efficiently, from my point of view, work with the mesh as you have worked with the CAD surfaces. Again, for example, we want to offset this surface because for whatever reason, this should be viewed later on. And I want to offset it with 2 millimeters, and I want to thicken it. As you can see now, we have thickened this area to the downward direction of the part. And same as in the CAD, working with the native CAD surface or NURB surface, we have now two closed meshes available, the general part and the offset part. And we can Boolean those together to get one single solid out of it. Sorry, there's something not working. And I have to take this one and this one. One other thing that I want to show you is you can also label STLs or mesh files. It's near the same procedure as we had before, so I have to add a work plane or an application point where I want to add the text or the logo. I want to now add here a certain text. In this case, it's hexagon, more or less. You can change the font, you can change the size and all of that. And now we have the profile here available, but as you can see, it's not wrapped onto the curved surface. So we again have to use the wrap functionality of Designer. So that's the profiles. The reference point should be this one. And the direction should be in the set direction. The surface where I want to apply it on is this curved surface here. And the application point is again this one. This one. And you can immediately see that the mesh has been changed in the background. Again, I want to deselect the profiles so that they are no longer visible. So again, we have imprinted now the logo onto, or the letters onto the surface. And now I can again move these into, for example, the positive direction. And I end up with the hexagon logo or the hexagon letters or text onto the surface. Okay. Last but not least, now we have generated the STL file or the STL file of the geometry, and I started beside the AM Studio. I can now load that part. It's this one that we have prepared beforehand in Designer. So there is the STL file. You can see this rod structure that we added here, and you can see the imprinted logo of hexagon. I want to use 0 distance to the base plate because the part has an offset on the bottom so that we can directly print on the base plate. Next step in AM Studio is to calculate the support regions and to add support structures. In this case, I want to use this tree-like structure here for that part. I would be able now to nest the part. I want to skip this part, and I can run a very rough estimation of the deviation of the part, so how it will deform during the print process. First, I have to mesh it, so we are generating a voxel mesh out of it, and we are using in AM Studio the functionalities of SimEffect Additive. We can also store the project in Nexus, and in SimEffect Additive we can consume the project so that we can run a very accurate simulation as well. So the embedded simulation capabilities in AM Studio shows how the part will deform during the printing. Yeah, exactly. If I'm happy with that, last step for the data preparation is to assign a certain slice and hatch parameter and run that. So now the slicing and hatching is started in the background, and we will end up in a machine file which we then can run on the printer. So we can see each and every vector, how it will be scanned on the machine itself or exposed, so we can exactly see how the individual vectors will be exposed on the machine itself. Okay, that's it from the workflow side. So back to the presentation. I have shown you in Designer how you can defeature a certain part, how you can clean up a part, you can modify the diameters, and how you can offset certain features, milling surfaces and stuff like that. Very easy and very quick in Designer. You can create labels or add labels, and you can directly work with meshes as well as you can work with native CAD files. In AM Studio, I have shown you in a very quick overview, the workflow of orientation was not necessary for that part. Support generation, running a quick process simulation, slicing and hatching, and the generation of the machine file itself. Once again, Designer, AM Studio, SimuFact Additive, and Osprey Edge are part of the additive manufacturing suite from Hexagon. And yeah, that's more or less it. If you want to get more information about Designer or AM Studio, you can contact Hexagon itself or me, Peter Leitner, or you can get more information on our homepage, Hexagon, where you can find under products, Designer and AM Studio, where there are a bunch more informations available. So thank you for everyone. I hope I gave you a good overview of the functionalities which are available in Designer for additive manufacturing. And I wanted to say thank you and goodbye. Have a good day. Bye.